Thanks, Greta. Hello and welcome everybody to this talk about building high-performance applications with the latest version of Spring Data Neo4j, Neo4j 4. I'll tell you a little bit about the company I work for. I work for GraphAware. We specialize only in Neo4j consultancy and software development training. And we can give you help with project guidance, long-term or short-term, as well as training and software development as well. And in addition to all of that, we have our own extension libraries for Neo4j that you can download, which are free, as well as an enterprise version of those things, which has more goodies in it if you have an enterprise license. Okay, so what are we going to talk about today? We've got about an hour, but I don't think we're going to need that much time. And so we'll probably have plenty of time at the end for questions. But really what I want to do today is to talk a bit about Neo4j itself and the Spring Data project, just as a bit of background, and a short history of Spring Data Neo4j before the current version. And then we're going to look at what's new in Spring Data Neo4j 4. We're going to see what's changed and some of the challenges we've had to overcome. And then we're finally going to have a look at a conference demo. This is an application that's been built using Spring Data Neo4j. It's a very simple application. We're going to look at the data model, some code. And if the demo gods are with us, we'll have a live demo as well. After that, I'm going to tell you a little bit about our plans for the next few months, our roadmap ahead, and hopefully then we can finish off with some questions and answers. So first I want to talk a little bit about Neo4j. Very briefly, many of you already know what Neo4j is, I'm sure, but equally many people may not know what Neo4j is and why graph databases are such a compelling technology these days. The key fundamental difference with graph databases, and Neo4j in particular, is that the underlying architecture of nodes and edges, they are both first-class citizens. In other words, they both participate in the data model. So unlike, say, for example, a relational database where you have your tables and your relationships are implied through foreign keys, in a graph database, you actually have real edges, or relationships as Neo4j calls them, physically actually part of your data model. This means that if you build your application data correctly, if you build your data model correctly and your graph database correctly, you have super fast traversals between things in the graph. Much, much faster than you would be able to do if you had to do joins between tables. So for localized data, graph databases are extremely compelling. Neo4j comes with embedded client mode and remote server mode now as well. So you can either run it locally in your own application, or you can do what most people are trying to do more and more these days, run as in an enterprise model where you have a remote server cluster perhaps of databases. A great thing about Neo4j and graph databases in general is that they're schema flexible. Some people will tell you that they're schema free, but nobody really wants schema free because it means you can put any meaning on your data. The schema flexible really means that you can add things into your graph database easily without having to reconstruct your data models. And finally, Neo4j has got the most powerful query language for graphs out there at the moment, Cypher. The Cypher Query language is quite incredible, and if you don't know it, we're going to see a little bit of it today, not very much, but if you don't know it, I do recommend you get to grips with it. It's very similar to SQL, but it's based on pattern matching in your graph. Anyway, so graphs are good for you, but the question happens, what happens when you try and get the data out of your graph and into a business model or a business application that you're trying to write? The real problem here is that the world of graphs is not the world of objects. We think and we design applications using concepts that are familiar to every day. We think of customers, we think of invoices, and we join those things up in our code with references, and the common paradigm is object-oriented programming. But all databases, not just graph databases, don't really like to store their data that way. And there are some object-oriented databases, but the majority of them have got their own data formats. And so the difficulty of translating to and from your graph representation to your business representation is something that people have been struggling with for a very long time. It's colloquially known as the impedance mismatch. This is originally a term that comes from the world of electronics. And generally, this tends to be solved in two ways. You either work directly with your data representation, so you work in the case of a graph database directly with the nodes and relationships, and sometimes that's the right thing to do. But for many applications, it's not convenient, and you need to have the abstraction of a data model, of an entity model on top of that, which is where object mapping libraries come in. Now, Spring Data was set up originally to try and address the problem of the impedance mismatch between different types of data stores and the way that programmers and developers want to work with their domain models. It is the most active Spring project, has most commits to it, and supports a large number of different database models now, JPA, almost all JPA, Neo4j obviously, but as well as document stores and key value stores like Redis. The great thing about Spring Data is that it will give you a convenient abstraction over all of these different data stores. If you're a Spring developer and you're using the Spring stack, these abstractions include things like your repositories, your queries, and your transactions, things that you have to deal with whatever data store you're using at the back end, but which you now have abstractions over for Spring. Spring Data itself, Spring Data Neo4j, has evolved from very early beginnings a few years back when it was Rod Johnson and Emil Ephraim started writing it. And since then it's gone through a number of different permutations, catching up, as it were, with the latest versions of Neo4j every single time something came out. But it suffers from one major problem, I suppose you could call it, which is that when it was first started, the only capability you could have with Neo4j was to run it embedded in your own application code. So you could not use a remote server. And as a result, the code was designed in such a way to make access to embedded databases through the Graph Database API very fast. But it was also very chatty. And so as a result, as more and more people wanted to start using Neo4j in server mode rather than embedded mode, this chattiness became something quite awkward to overcome. And many people finding that they were spending a lot of time just waiting for responses, getting a node out from the graph or a relationship out. And it was time for something different. So now we have Spring Data Neo4j 4, new and shiny, and it has a complete rewrite. We decided that since the focus was shifting towards the server side rather than embedded, we would focus only on the server. We also wanted to make sure that we were sympathetic to the typical business use cases that you'd find in web applications. And also the other thing we thought was really important was that Spring Data Neo4j 1, 2, and 3 really was only available to users, developers who were part of, who used the Spring stack. And we didn't think this was A, fair, and B, it cut a lot of people out who don't use the Spring stack. So we've made sure that Neo4j 4, Spring Data Neo4j 4, can be used not just for Spring developers, but also for people who aren't using the Spring stack. Where are we? Well, we started development in September 2014, and we're now 9 months later and just about to release the first release candidate. Milestone 1 was released a couple of months ago, and we should be at GA, full GA, by mid-June. We've done an awful lot of work in that time. We've got about more than 20,000 lines of code and close on 700 tests in the space of 9 months. So although it's a work in progress, there's a lot been done to date. So the main thing was, the big decision for us was to separate out Spring Data part from the standalone Java OGM to enable people who didn't want to use Spring to take advantage of the OGM, but to make sure at the same time that all the added goodness of Spring was available, template methods, transactions, repositories, and so on and so forth. So the OGM side of things was decided, well, if you know Hibernate, it'll be quite familiar to you in some ways, although some of the issues that we have with Hibernate, that people have with Hibernate, hopefully we don't have at the moment, and hopefully we won't have. Our biggest constraint was the problem that when we're running across the network, there's only one communications protocol available right now, which is Cypher over HTTP. And Cypher is a text-based format. And so our big concern was, how are we going to make this performant for people? We had to make sure that we maximize the signal-to-noise ratio. We wanted to make Cypher queries as efficient as possible, whereas before we were only getting a small part of your data model every single time. We thought there must be better ways of doing this. One thing that was important to us, that we didn't want to send any updates to the database that didn't actually change anything. It would just waste CPU cycles, increase latency, and so on. And at the same time, we wanted to do as much as possible for the user to help them do what you'd normally expect to be doing, but leaving them also in ultimate control to change those things if we were doing things that didn't exactly match what they want to do for a particular case. So the main features that we developed to implement this were a number of different things. The first is our metadata scanning doesn't use reflection at all. It reads the class files directly. It's much faster, hundreds of times faster to do this. And if you're running in an environment where maybe you're running a clustered environment or you're running some kind of microservices and Neo4j is taking part in that, and one of your servers goes down, startup time is important. And so we felt this was something worthwhile doing. And in fact, you know, now you start up an application, you can rescan 1,000 classes in less than a second. The other thing that was important to us was that although we wanted to keep annotations, we also wanted to make it easy for people who have very simple data models. They didn't need to put annotations on their code at all. So we can also work without annotations. Obviously, there are some limitations without annotations, but if you have a simple data model, you can get by without using any annotations. The other thing we wanted to do was to make sure that the mapping context, while you're actually working with Spring Data Neo4j, was scoped to the conversational lifetimes that you're used to. So if you've got a long-running application, perhaps, then you can keep your mapping context open for the duration of that application. If you're running an HTTP session or request-based or so on, you can change the scope accordingly. And what that gives you is the ability to do smart object mapping. We can detect what has changed, what you have changed. We can detect deleted relationships. We can detect if an object itself is dirty or not, whether you've changed it, which means that we can construct efficient Cypher, both sending data to the database and retrieving data back from the database as well. And one of the most important aspects, we think, to help us do this has been what we call variable depth persistence, which I'm just going to talk a little bit about for now. So variable depth persistence is important for both reading and for writing. And the read case is quite obvious when you think about it. Most of the time when you're writing a business application of some sort, you're going to be in a sort of master detail view of the world. The vast majority of business applications are the sort of customer, orders, product lines, etc. So very often when you're looking for one thing and you're very interested in one thing, you're actually very often interested in things that are immediately associated with it as well. And as a result, we decided as a default that when you loaded an object, you would by default get all of the associated objects around it, but not their associations. So you get all your associations and their properties, but not the second level out. And this is the default. We call this search depth of 1. And then you can obviously change that. You can have a search depth of 2 or 3 or 4, depending. For lists, of course, you probably don't want to do that. If you're just interested in getting a list of customers, you'd probably want to set your search depth to 0 for that. But the whole idea of variable depth persistence, it allows you to choose according to how you need your application to operate at a particular point in time. The other side of the coin is writing. And we took the view that if you have connected domain objects, reachability was an important concept. You should be able to save all of them, regardless of which ones you've changed in that object domain, all at once from any object. So rather than have to save the customer and then his orders and so on and so forth, you save the customer, and any orders that have also been modified also get changed as well, or also get saved as well. So the idea was that if your graph is reachable, we will persist it for you without you having to explicitly tell us exactly what to persist. So that default is obviously we will reach into as far into your data model as we can, but again, that's controllable by you. You can say how far you want to go in. You can specify that you only want a depth to go to 1 or 2 or 3, for example, if that's all you know that you need to do, and you're not interested in saving things that have changed for the time being. And the final point about variable depth persistence is that although these defaults are set and you can change them, fundamentally you're also finally in very fine control because you can use queries as well to traverse the graph and get exactly the nodes and relationships you want out and have them hydrated as objects in your domain model as well. So what we're going to do is to look at a conference application, very simple CRUD-based application based on the new Spring Data Neo4j 4, using Spring Boot and the front end written in AngularJS. The application architecture is very straightforward, simple REST controllers, which themselves depend on services and then again on repositories and obviously persisting your straightforward POJO entity classes, the same sort of thing you'll have seen many, many times. In terms of the objects we're going to persist, this is just a quick list of those objects and their relationships. We have speakers, a conference, tracks, a talk, time slots, and various relationships between them. For example, the speaker presents a talk, the speaker's registered for a conference, and so on and so forth. The interesting thing to note here is that entity names or class names in your Java application are not necessarily going to be the same as the labels you've got on your nodes in the graph database. So in this particular case here, we have an entity called talk, but it's represented by a label in the graph called session. And we'll see how we can overcome that slight impedance mismatch when we look at the code. So this is our basic graph model. Now you'll notice here that all of our relationships are directed. Neo4j requires directed relationships. You can't have an undirected relationship in Neo4j, which means that when you're declaring relationships between objects, and again we'll see an example of this, you need to specify whether it's incoming or outgoing from the perspective of the object who's looking at the relationship. Now there's many, many different ways of preparing your data to load into Neo4j. Load CSV is a function that's available actually directly in the browser and can load a CSV file for you, and has got lots of transformations you can do as well. It's very fast. You can also use the batch inserter. There's the Neo loader from GraphAware. A number of different tools are available. But I just created a small CQL file, which is a Cypher Query language file. This is an example of the beginning of it here. So I could save it as a script and reproduce it again and again and again whenever I needed to reload the data. You'll notice the Cypher itself. This is probably a very simple example of here, but you can see how we have our nodes are on the left-hand side. We've got our relationships in the middle with arrows pointing the direction we want, and then a node on the right-hand side again. And basically, a node relationship node is the fundamental unit in a graph. It's a path, basically. If you just had nodes, you just basically have a very poor list. So the fundamental unit of interest in the graph is a path, and Cypher allows you to describe paths very, very easily. So once the data is loaded, there it is, it all goes in there, and there's a nice little pretty shot of what it looks like. So when the data's in, the next thing we have to do is talk about the code itself. We want to have a look at how we've built this application. So I'm going to start just basically with the configuration classes, then we're going to look at the entities, the repository, the services, and the controllers, all of which obviously need to work together to make your app. But you'll see that it's actually extremely simple. So the first part is the configuration of Spring Boot itself. Nowadays, the latest version of Spring Boot, you just have to say that you want a Spring Boot application. The annotation at Spring Boot application does a lot of magic behind the scenes for you. And then you just need to say, and this is what I would normally do, I would keep my configuration for Spring Boot separately from my persistence configuration, which we're going to have a look at in a minute, and just import it in so Spring is aware that there's an additional configuration class it needs to include. So this is the configuration for our persistence, and this is where we start beginning to see how Spring Data Neo4j differs from SDN3 and earlier versions. The first thing is the enable Neo4j repositories, which you still use in SDN3, and where you need to define where your repositories are, app conference repository in this case, and that allows Spring to go and construct the repository proxies for you, and so on and so forth. We also enable transaction management. You don't have to, but if you do, then you'll participate automatically in Spring's transaction management. The three beans that we declare are the only ones that you need in order to get Spring Data up and running in your application. The first is you need to declare where your server is. In this case, we've got a remote server, which basically means it's running across the wire somewhere. And in this case, it's running on this machine on the standard Neo4j port. We also have for testing an in-process server you can use as well. So you can just say return new in-process server there, and you can run that in process. And it's actually a community server edition, which is running in your own application code. Obviously, for production, you wouldn't want to do that. The most important thing is the session factory itself. This is very similar to the Hibernate session factory. And the important argument to there is where your domain classes live. This is the path to your domain classes. They will be scanned with this very fast class path scanning that we talked about earlier, and they will form the metadata mapping for your object model, how it's going to be mapped to and from the graph. And we're going to look at those entity classes in a second. The final thing is the session itself. We talked about a little bit about how you can scope your session to your conversational interests. So it could be application-based or HTTP session or session request, HTTP request. Here we've set ourselves to be HTTP session, which is what I would normally expect to do for a web application. You could make it smaller duration. The advantage to having it as long as possible is it means that we can generate more efficient Cypher because we can remember more about what you have and haven't done when you've loaded data, when you've saved changes, and so on and so forth. And we can discard stuff that we know isn't going to make a change to the database. The shorter your life cycle is, your session life cycle, the more hard it is for us to figure what's the best thing to do for you. So my domain classes for this are very simple, and because they're all the same, I decided I was going to use an abstract entity as sort of the root class for all the other entities themselves, because I just need every entity's got to have an ID on it, and it's also got to have a name so I can know what it looks like and what it's called. One thing I'd like to point out to you when we're looking at JSON generation of objects, graphs in particular, is that JSON is very bad at doing anything with cycles in. As any of you have tried to struggle with trying to make it not send certain things down, transform certain things. There's a generator called JSOG, which I recommend you use if you're interested in sending entire graphs down, anything which includes cycles, because it handles it absolutely perfectly. There's even, if you're rendering in JavaScript, there's even a JavaScript library as well on the receiving side that can communicate on both sides for you. So then all you need to say is that your JSON property here is our ID. Now the first thing here that's Neo4j related, or Neo4j Spring Data Neo4j related, is the graph ID annotation. This graph ID annotation isn't required if your identity field is of type long and is called ID. That's the default. If you have got a field called long ID, we'll assume it's the identity field, and you don't need to annotate it with graph ID. If your identity field is something different, you will need to annotate it with graph ID. So, moving on. This is the first case here where we're seeing a relationship. Now, in Spring Data 3 and previous versions, relationships, you had to annotate them differently, whether they were represented by a relationship entity or not. And by a relationship entity, what I mean is, if we take a look at the example between speaker and session here, we have a presents, a relationship between the two. Now, unless, if you have no properties on that presents relationship, then it's easy to represent it in your domain models as a simple object reference between the two objects, the speaker and the session. But that's not possible, of course, if there are properties on that relationship, and Neo4j, being a fully fledged property graph, lets you do that. In which case you have to use a relationship entity. Now, when you're referencing an object which is referenced via a relationship entity or not, we still use the same tag, relationship, because it is a relationship that you're defining. And in this case, we say the type equals presents, which is the label we want on that relationship. And you'll notice as well that the object that we are referring to is a talk object, which is our domain entity class name. But in fact, in the graph, it's called a session, and we're going to come to that, how that's managed in a second. So that's very simple. Our speaker just presents talks. I think we have some other relationships to speaker as well, such as registering for the conference, but I haven't bothered showing them here. So the talk object is the next one that we're interested in. And here we'll see that we've had to annotate this class with the annotation node entity. And we specified that the label we're interested in is session. And this will allow Neo4j, Spring Data Neo4j, to bind the session label to the talk entity. If you don't want entities bound at all, but they're part of your domain model, you can mark them with an @transient, or you can make them abstract, and they won't persist. The other thing that's important here is to look at is the three relationships that we've specified here between the talk and its related objects. We have a time slot, a track, and the speaker, or the set of speakers who are presenting that talk, because a talk can be presented by more than one speaker. In the case of the speakers, we notice that we have to specify the relationship is incoming. And if you look at the diagram there, you can see that, in fact, from the session's perspective, the presents relationship, the arrow is pointing at the session. This means the relationship is incoming. By default, if you don't specify that, we'll assume that the relationship is outgoing. The other two relationships on this particular class have not specified a direction, and so therefore we've assumed it's outgoing. And in this case, they are outgoing, so that's fine. But if you don't specify it, and it's the wrong way around, your object won't be hydrated. You won't get that relationship information being loaded. When you load the session, you won't load the thing that's the object that's related in the wrong direction. So that's enough on entities for now. The next thing to look at is the repositories. As you're probably aware, with Spring, you only need to specify an interface to get all of the basic CRUD stuff that you need: read, write, delete, find one, find all by type, and so on and so forth. But very often you want to extend your repository with additional methods that suit your particular application. In this case, I've written a very simple query which demonstrates a bit more Cypher. A very simple Cypher query where we're interested in matching a speaker to anything, all the talks I present, and we're interested in then counting how many talks that speaker presents and just ranking them on that basis. It's a very, very simple query. Then we're going to return that, in this case, because we have an object and an aggregate, we're going to return it in an iterable, so we can extract the object later. From the services point of view, again, a similar kind of concept, again, an abstraction of the base service, because all of our entities basically follow the same pattern. There's a master detail view for all of them, so the services follow the same pattern and so on. The important thing, or an interesting thing to notice here, is something I mentioned earlier about the variable persistence depth. What we've done is to override the FindAll and find methods here. Because for FindAll, we're only interested in getting lists of things, and I'm not interested in finding all the other objects that are associated with, say, a list of speakers or a list of talks. I just want the talks themselves or the speakers themselves. So I set the depth for a list to be 0. So I'm now going to, when I fetch that data, I'm only going to get the related nodes. I'm not going to get any objects associated with those nodes through relationships. But on the other hand, when I find an instance of one of those things, a talk or a speaker, I'm actually interested in knowing what it's related to, its immediate relations. I could have set that to anything, but I set it to 1, which is actually the default. So I'm going to get the talk and all its related speakers, tracks, and so on and so forth. That means that the service implementation is extremely simple. You just have to wire your repository in and then just return your own repository whenever the generic service asks you for your specific one. Controllers also take a similar idea of an abstraction. In here we have a base request mapping value, API, which means that all of our controllers are going to start with /API as their root. And it's an extremely simple model to follow. We also have to make sure that the actual controller itself, the instance of the controller, can return its own service when this controller needs it. So we have an abstract method getService, which we'll see implemented here. REST controllers are good in the sense they don't need a response body. So you can quite easily write them, quite quickly write them. And here we just created a very simple one. We've mapped the list of talks to the talks URL, so it'll be API talks. And there's more methods, obviously, but this is the easiest one to show you, the quickest one to show you. So as you can see, it's actually really, really simple to set up a basic CRUD application using REST controllers, using repositories and services and so on, with Neo4j backing it. So the front end, I'm not going to show any code for the front end because it's too small just to fit on the screen to see stuff, but a very simple CRUD application based on JHipster. So every JSON entity that we're looking at basically is just supported by 5 files: config, service factory, controllers, list, and detail. And if you're interested in looking at the code, it's available online in the Spring Data Neo4j examples repository. It's called SDN Conference, and you'll be able to find it there if you're interested in looking at it further. So now let's have a look at the application, see if we can get this working. There we are. So the first thing we're going to have a look and see is these are the entities. We've got talks. There they are. We've got some speakers. And we've got some tracks. Very simple. So the first thing I'm going to do is I'm going to see what I'm going to find a talk. Let's find the first talk here. And I can see that the speaker here is Josh Long. And I've decided that Josh actually needs some help. So I'm going to give Ivan, he's going to help this talk as well. And obviously this UI is not the prettiest UI, I'm sure. I wouldn't claim to be the best UI developer in the world, something we knocked up at about 10 minutes. So I'm sure we could do better with a bit more time. But just for showing the functionality, it's fine. So we've set Ivan on here, and now I want to go and find Ivan and make sure that he actually is doing this talk. So, oh, there he is. And was he doing the talk? Maybe not. Oh, I didn't save it, that's why. Let me go back again. So let me set that talk up again. And let's add Ivan, and I forgot to save. So now I can save and find Ivan, and there he is. So he's now doing 2 talks, whereas before he was just doing 1. So I'm going to remove him from here. Save that. I'm going to go back to the talk to check that he's gone, and he has. So all this is being done. Now, one of the things I mentioned earlier to you is that we actually can save the entire object model with just one, when you save one object. And this is exactly what's happening here. I'm not having behind the scenes, there's no code in here saying, oh, I've saved, I've deleted Josh from here, I've deleted Ivan from there, now I must go and do this. This is all happening behind the scenes for you. The collections on both sides are being managed for you. So you only need to do one thing if you have connected data like this. So now I'm going to create a new track. I'm going to speed up a little bit because I know we've not got much time left. So I'm going to create a new track now. I'm going to call it the workshop track. And yeah, I'm going to add, there we go, I've got something for a workshop there already. I'm going to add that to it and save that. So now if I go and have my workshop track, I can see I've got a using Groovy to empower WebRTC network systems. The other thing I can do is go and say, right, look, existing tracks already got, say, a business track. I don't want this on that business track, or so on. I can remove objects from tracks and so on and so forth in exactly the same way. So I've got full control of create, read, update, and delete. And I can now decide, actually, I don't want my workshop track anymore. So I'm going to delete it. And it's gone. All very good. The last thing I want to show you very quickly before we get into the final part of the presentation today is I just want to show the report. Remember that query we talked about, which was finding presenters? So these are the popular speakers. We can see that Josh is by far the most popular speaker. He's got 4 talks going on. Where am I? I've only got 1. Well, that's not very good. So let's find myself. And let's give myself a bunch of talks because I've got to outdo Josh. There we are. Okay, 8, twice as many as Josh. Fantastic. So that's it on terms of the demonstration. Very, very simple, but really, really easy to write that code and get a working application up very, very quickly. Obviously, you'd want to spend a little bit more time, perhaps, on the UI than I did. But just to give you an example of what we can do and how it works with Spring Data Neo4j. So, where are we going next? Well, immediately after release candidate 1, which is due out next week, we're going to start a project code split. Right now, everything is under one repository, and we'll be moving that now to a separate OGM part, which is going to be living in the Neo4j repositories, and the Spring part will be living in the Spring repositories. And that will allow us to make more regular updates to the OGM side of things so that people can take advantage of bug fixes and new features more quickly than otherwise would have been possible. We're going for general release mid-June, and then we've got more features planned after that. Dynamic properties, for example, support for embedded Neo4j has been asked for. Versioning of objects as well. Neo4j version 3, which is out next year, in 2015, 2016, is going to have multi-version concurrency control, so we'll be hooking back into that, hopefully. We've got the binary protocol coming up as well, which will make access to Neo4j even faster than it currently is. And we'll also be able to put in hooks to pre, post, save lifecycle events and so on. So there's a lot of stuff still to do, but we're already a long way along the road. And if you haven't tried out Spring Data Neo4j yet, I would recommend you do so. And to get started, there's some URLs here. There's where you can download Neo4j. You can download this conference application itself, and you can find the latest documentation and so on. The current release is M1, but probably by the time you get to look at this, it will be at RC1. I encourage you, please, if you're interested, please have a look at this. Let us know as well how you like it. And if you need any help and you want to track an issue or raise an issue, then go to Jira, Spring.io's Jira data graph, and raise a ticket there. If you've just got questions or you need some advice, then there's always our blog. We're always posting things on our blog. And failing, if you don't find an answer there, look in Stack Overflow. We're always monitoring Stack Overflow. So please help us, help you by putting questions on Stack Overflow. This is the team here, Luan, Adam, and myself. We're always very pleased to answer your questions on Stack Overflow as well. So thank you very much. That's it from the point of view of the presentation. I hope you've enjoyed it.